Welcome to Electronics and Robotics class. I am Junamalan P. Sepulveda, your teacher for this school year. In today's lesson, we will go back to the timeline of electronics wherein we will be able to understand and appreciate the development of electronics technology. Are you ready? Let's begin. At the end of the module, it is expected that you will be able to 1. Recognize the invention of scientists in the development of electronics. 2. Identify the most significant invention that contributed in humankind. For online learning, open your Google Classroom or Facebook group page and click the link posted by your teacher. For modular learning, get your printed module and open the post test on page. Write your answer in the answer sheet provided. Welcome to the world of electronics, one of the newest, most useful, and fascinating of the applied sciences. In today's high-tech world, electronics can be an educational and entertaining hobby or career. You probably know that electronics has made many high-tech devices possible, such as televisions, DVD players, CD players, amplifiers, and computers. Electronics is a branch of physics and technology that deals with the emission, behavior, and effects of electron with the design of circuits using its components. Are you ready for our first activity? Grab your pen, answer sheets, and look into your module. Instructions. Look around you. How many devices and appliances do you have at home? List it down according to your daily needs. You have 10 minutes to finish this activity. Start now. Let's see if you answered correctly. How many device and appliances did you write? Check as many as you can. You may send the picture of your output through the link that will be given by your teacher. Are you ready for another activity? Let's find out together. Grab your pen, answer sheets, and look into your module. Activity 1 is entitled Compare and Contrast. Instructions: look at the image below, compare the following image in connection with the development of electronics technology. Activity 1 is entitled Compare and Contrast. Instructions: look at the image below, compare the following image in connection with the development of electronics technology. Activity 1 is entitled Compare and Contrast. Instructions: look at the image below, compare the following image in connection with the development of electronics technology. Activity 1 is entitled Compare and Contrast. Instructions: look at the image below, compare the following image in connection with the development of electronics technology. Activity 1 is entitled Compare and Contrast. Instructions: look at the image below, compare the following image in connection with the development of electronics technology. Activity 1 is entitled Compare and Contrast. Instructions: look at the image below, compare the following image in connection with the development of electronics technology. Please answer the following guide questions. 1. Does the following devices/components match in the list of your appliance at home? 2. Name the appliance that you found similar among the given examples above. 3. How will you now differentiate the present technology with the previous one? Let's see if you answered correctly. Now, get your module and check your answer honestly. Are you ready for another activity? Let's find out together. Grab your pen, answer sheets, and look into your module. This activity is entitled, Meeting with the Famous Scientists. Label the names of each scientist and write their significant contribution in electronics technology in 1 to 2 sentences only. Please start now. You're doing great. Were you able to recognize each scientist? Now, check your response if you answered correctly. Let's see if you answered correctly. Now, get your module and check your answer honestly. The introduction of vacuum tubes at the beginning of the 20th century was the starting point of the rapid growth of modern electronics. With vacuum tubes, the manipulation of signals became possible, which could not be done with the early telegraph and telephone circuit or with the early transmitters using high-voltage sparks to create radio waves. The development of a large variety of tubes designed for specialized functions made possible the swift progress of radio communication technology before World War II and the development of early computers during and shortly after the war. In 1745, Andreas Cuneus, an assistant in the laboratory of Peter von Muskenbroek in Leiden, attempts to condense electricity in a glass of water. 2 wires were suspended in the water. Leyden jar is the first electrical capacitor, a shortage mechanism for an electrical charge. Flying a kite in a storm was perhaps Benjamin Franklin's most famous experiment that led to the invention of the lightning rod and the understanding of positive and negative charges. The connection between electricity and lightning was known but not fully understood. By conducting the kite experiment, Franklin proved that lighting was an electrical discharge and realized that it can be charged over a conductor into the ground, providing a safe alternative path and eliminating the risk of deadly fires. Franklin hypothesized that lightning was an electrical discharge. Before he thought of conducting his experiment by flying a kite, he proposed erecting iron rods into storm clouds to attract electricity from them. He also suggested that the tips of the rods should be pointed instead rounded so that they could draw electrical fire out of a cloud silently. Franklin speculated about its usefulness for several years as he was unable to perform his experiment since he thought it had to be conducted from a higher ground. Philadelphia has a flat geography and at the time there were no tall structures. He was anxiously waiting for the construction of Christ Church that was being built on a steeple to conduct his experiment. Franklin wrote his proposal for the iron rod experiment in a letter to Peter Collison, who was a member of the Royal Society of London. Collison presented Franklin's hypothesis to the Society, who ridiculed and laughed at his idea, failing to recognize its significance. A year later, when the French translation was published, it attracted the interest of French scientists Deller and Dalibard, who separately and successfully conducted Franklin's experiment, calling it the Philadelphia experiment. Source: BenjaminFranklinHistory.org. In 1799, Alessandro Volta developed the first electrical battery. This battery, known as the voltaic cell, consisted of 2 plates of different metals immersed in a chemical solution. Volta's development of the first continuous and reproducible source of electrical current was an important step in the study of electromagnetism and in the development of electrical equipment. The unit volt for electromotive force was named after him. Source: fw.org. Milestones. A French mathematician and physicist named André-Marie Ampère was inspired by this demonstration to work out the connection between electricity and magnetism. He found that if you put 2 wires parallel to each other and pass current through them, the wires will either be attracted to each other or repulsed depending on whether the currents flow in the same or opposite directions. This is because each wire generates a magnetic field. The longer the wires, and the higher the currents passing through them, the greater the magnetic repulsion or attraction. This ampere, called the International Ampere, was not the ampere that scientists use today. Instead, this ampere was realized transformed from definition into practical reality with a device called a silver voltmeter. This device contained electrodes with positive, anode, and negative, cathode, terminals. The anode was suspended in a solution of silver nitrate. When current passed through the device, silver would accumulate on the cathode. Researchers would then determine the mass of the cathode before and after. The amount of silver on the cathode indicated how much current had passed through the device. The life of André Marie Ampère, the man who formulated the law of electromagnetism, often known as Ampere's law, and who gave his name to the amp, the unit of electrical current. He was one of the pioneers of modern electronics. He effectively made the first electrical measuring instrument, electronic test equipment, thereby enabling people to understand how much current was flowing in a circuit. Along with his mathematical derivations of electricity, he made a truly major input to the early science of electricity. In 1820, a Danish physicist, Hans Christian Ørsted, discovered that there was a relationship between electricity and magnetism. By setting up a compass through a wire carrying an electric current, Ørsted showed that moving electrons can create a magnetic field. The magnetic field created by the current goes in circles around the wire. Source: scienceworld.ca. Charles Babbage, English mathematician and inventor, who is credited with having conceived the first automatic digital computer. The idea of mechanically calculating mathematical tables first came to Babbage in 1812 or 1813. Later he made a small calculator that could perform certain mathematical computations to 8 decimals. Then in 1823 he obtained government support for the design of a projected machine, the difference engine, with a 20 decimal capacity. Its construction required the development of mechanical engineering techniques, to which Babbage of necessity devoted himself. Self-taught British scientist Michael Faraday built the first primitive motor about 1821, shortly after the discovery that an electric current produces a magnetic field. His motor featured a stiff wire in a container of mercury, a metal that is liquid at room temperature and an excellent conductor, and a permanent bar magnet in the center of the container. He sent electricity through the wire and created a magnetic field around it. This field interacted with the field around the magnet and caused the wire to rotate around the magnet. Even though it had no practical application, Faraday's invention was the first step in the evolution of the electric motor. Other scientists quickly made improvements on it. A few months later, British physicist William Sturgeon developed the first rotary electric motor, a forerunner of the present-day direct current motor. The electric light wasn't Thomas Edison's first invention, nor was he the first to create an alternative to gaslight. Electric lights already existed on a street light scale when, on this day in 1879, Edison tested the one he's famous for. Though he didn't come up with the whole concept, his light bulb was the first that proved practical, and affordable, for home illumination. The trick had been choosing a filament that would be durable but inexpensive, and the team at Edison's invention factory in Menlo Park, New Jersey, tested more than 6,000 possible materials before finding one that fit the bill: carbonized bamboo. Edison bragged about the filament's efficacy and economy to a New York Times reporter who toured the factory just after his successful test run. "As there is no oxygen to burn," said Mr. Edison, "you can readily see that this piece of carbon will last an ordinary lifetime. It has the property of resisting the heat of the current of electricity, while at the same time it becomes incandescent, and gives out one of the most brilliant lights which the world has ever seen. The cost of preparing one of these little horseshoes of carbon is about 1 cent, and the entire lamp will cost not more than 25 cents. While Edison considered the invention his crowning triumph, it joined the long list of contributions that made him a record holder for sheer number of U.S. patents: 1,093 until the 21st century. His creations included the movie camera and the microphone, the phonograph and the mimeograph, the stock ticker and even the stencil pen, a precursor to the tattoo gun. And although his accomplishments spoke for themselves, Edison was equally prolific, and ambitious, in inventing myths to boost his reputation as a larger-than-life innovator, as a 1979 Time profile notes. As a result, his inventions weren't just scientific discoveries, but also prevarications. Source: Time.com. Nikola Tesla wanted to create the way to supply power without stringing wires. He almost accomplished his goal when his experiment led him to creation of the Tesla coil. It was the first system that could wirelessly transmit electricity. From 1891 to 1898 he experimented with the transmission of electrical energy using a radio frequency resonant transformer of the Tesla coil, which produces high voltage, high frequency alternating currents. With that he was able to transfer power over short distances without connecting wires. However, the Tesla coil does not have much practical application anymore. Tesla's invention completely transformed the way electricity was comprehended and used. Radios and televisions still use variations of the Tesla coil today. Source: sites.suffolk.ed. The history of electronics began to evolve separately from that of electricity late in the 19th century with the identification of the electron by the English physicist Sir Joseph John Thomson. Thomson's most important line of work, interrupted only for lectures at Princeton University in 1896, was that which led him in 1897 to the conclusion that all matter, whatever its source, contains particles of the same kind that are much less massive than the atoms of which they form a part. They are now called electrons, although he originally called them corpuscles. His discovery was the result of an attempt to solve a long-standing controversy regarding the nature of cathode rays, which occur when an electric current is driven through a vessel from which most of the air or other gas has been pumped out. Nearly all German physicists of the time held that these visible rays were produced by a currents in the ether, a weightless substance then thought to pervade all space, but that they were neither ordinary light nor the recently discovered X-rays. In 1909 Millikan began a series of experiments to determine the electric charge carried by a single electron. He began by measuring the course of charged water droplets in an electric field. The results suggested that the charge on the droplets is a multiple of the elementary electric charge, but the experiment was not accurate enough to be convincing. He obtained more precise results in 1910 with his famous oil drop experiment, in which he replaced water, which tended to evaporate too quickly, with oil. Source: Britannica.com. Armstrong was one of the great pioneers of early radio communications or wireless technology in 1933. He also invented the regenerative radio, superheterodyne radio and wideband FM. At age 14, fired by reading of the exploits of Guglielmo Marconi in sending the first wireless message across the Atlantic Ocean, Armstrong decided to become an inventor. He built a maze of wireless apparatus in his family's attic and began the solitary, secretive work that absorbed his life. Except for a passion for tennis and, Later, for fast motor cars, he developed no other significant interests. Wireless was then in the stage of crude spark gap transmitters and iron filing receivers, producing faint Morse code signals, barely audible through tight earphones. Source: Britannica.com. The discovery of radio waves, which was widely seen as confirmation of James Clerk Maxwell's electromagnetic theory and paved the way for numerous advances in communication technology, was made by German physicist Heinrich Hertz. He received a Ph.D. magna cum laude from the University of Berlin in 1880, where he studied under Hermann von Helmholtz. In 1883 he began his studies of Maxwell's electromagnetic theory. Between 1885 and 1889, while he was professor of physics at the Karlsruhe Polytechnic, he produced electromagnetic waves in the laboratory and measured their length and velocity. He showed that the nature of their vibration and their susceptibility to reflection and refraction were the same as those of light and heat waves. As a result, he established beyond any doubt that light and heat are electromagnetic radiations. The electromagnetic waves were called Hertzian and, later, radio waves. He was not the first to produce such waves. Anglo-American inventor David Hughes had done so in work that was almost universally ignored in 1879, but Hertz was the first to correctly understand their electromagnetic nature. In 1889 Hertz was appointed professor of physics at the University of Bonn, where he continued his research on the discharge of electricity in rarefied gases. In 1896 Marconi took his apparatus to England where he was introduced to Mr., later Sir, William Preece, engineer-in-chief of the Post Office, and later that year was granted the world's first patent for a system of wireless telegraphy. He demonstrated his system successfully in London, on Salisbury Plain and across the Bristol Channel, and in July 1897 formed the Wireless Telegraph and Signal Company Limited, in 1900 renamed Marconi's Wireless Telegraph Company Limited. In the same year he gave a demonstration to the Italian government at Spezia where wireless signals were sent over a distance of 12 miles. In 1899 he established wireless communication between France and England across the English Channel. He erected permanent wireless stations at the Needles, Isle of Wight, at Bournemouth and later at the Haven Hotel, Poole, Dorset. In 1900 he took out his famous patent number 7777 for tuned or syntonic telegraphy and, on an historic day in December 1901, determined to prove that wireless waves were not affected by the curvature of the Earth, he used his system for transmitting the first wireless signals across the Atlantic between Poldhu, Cornwall, and St. John's, Newfoundland, a distance of 2,100 miles. Source: Nobelprize.org. While Jack Kilby was conducting research into miniaturization, he built the first true integrated circuit, a phase shift oscillator with individually wired parts. Sir Edward Victor Appleton was one of the key figures of the 20th century who contributed to the knowledge of radio and the ionosphere and hence improved our knowledge of the way in which radio waves propagate in the HF portion of the spectrum. One of the most famous and influential inventions to come out of the Bell Labs was the transistor. As the first solid-state amplifier or switch, the transistor replaced the vacuum tube, perhaps making science fiction movies less visually interesting, but paving the way for some real science, as the transistor helped lay the foundation for modern electronics. Shockley, Bardeen, and Braddon initially were studying the properties of germanium crystals and whether they could be used as semiconductors, as part of an attempt to replace troublesome, high-maintenance vacuum tubes as mechanical relays in telecommunications. The research led to the invention of the point-contact transistor, which, when electrical current was applied to one gold foil contact, amplified the current via the germanium, thereby boosting the strength of the current flowing through the second contact. The team quickly improved on this device, developing the junction transistor, which was first used commercially in 1952 with the sonotone hearing aid. The first transistor radio was manufactured in 1954. In 1956, the team received the Nobel Prize in Physics for their invention. Source: fiercetelecom.com. In 1972 Cray left Control Data and founded his own firm, Cray Research Incorporated, with the intention of building the fastest computers in the world. This was largely realized through his innovative design of uniprocessor computers, which allowed simultaneous, parallel, processing. His company's first supercomputer, the Cray 1, which came out in 1976, could perform 240 million calculations per second. It was used for large-scale scientific applications, such as simulating complex physical phenomena, and was sold to government and university laboratories. Further supercomputers followed, each with increased computing speed. Cray resigned as chairman of his growing firm in 1981 and became an independent contractor to the company, designing ever-faster machines at his laboratory in Chippewa Falls. Cray was a pioneer of dividing complex computations among multiple processors, a design known as multiprocessing, and his Cray XMP, 1982, was one of the first machines to use multiprocessing. In 1985 the Cray 2 was introduced to the market. This machine, which was cooled by fluor-inert electronic liquid, could perform 1.2 billion calculations per second. The Cray YMP, introduced in 1988, was capable of 2.67 billion calculations per second. In 1989 Cray founded the Cray Computer Corporation. However, as microprocessor technology advanced and the demand for supercomputers fell in the post-Cold War era, Cray Computer filed for bankruptcy in 1995. Undaunted, Cray opened another company, SRC Computers, LLC, in August 19, 1996, but he died 2 months later following an automobile accident. Source: Britannica.com. Were you able to recognize them all? You're doing great. Give yourself a tap on your back and say good job. Now, let's try some more activity to further enhance your understanding. Are you ready? Electronics technology had continuously provided convenience to people through the development of computers with touch screen, sensors. It builds digital communication faster, security, and it also creates entertainment. In this time of pandemic, we can be able to gain more knowledge through internet and digital platforms that is placed right in our hands with a bunch of data. Electronics technology is the application of scientific theories and principles in the design, production, installation, testing, service, use, and control of electrical and electronic parts, equipment, and systems. That ends our lesson for this week. I hope you learned something from this session. Do you have any questions? Feel free to ask me through emails, chat or text messages. I have learned that. I wish to ask my teacher about. You may send your answer through chat or emails provided by your teacher. For online learning, open your Google Classroom or Facebook group page and click the link posted by your teacher. For modular learning, get your printed module and open the post test on page. Write your answer in the answer sheet provided. Additional task, answer the following questions. 1. List down 5 implications for future innovation throughout the electronics industry. 2. Identify the pros and cons of each invention in relation to the improvement of lives of people. Congratulations on finishing this module. You did a great job. Keep learning and be safe at home. Till next time.